Awesome. Okay, our next presenter is going to be Michael Gibson with Fortress Power. Michael, are you here?
Yes, but I'm hiding.
Okay, you hide. Do what you want to do, Michael.
I'm shy.
I'm like, this is the luxury of being on Zoom.
Um,
Okay, so do your introduction. Michael Gibson is an electrical engineering graduate from the University of Delaware. His 20 plus years experience in electrical power distribution industry. Presently, he is Fortress Power's Director of Commercial and Industrial Solutions. Over the course of his career, he has worked in residential, OEM, industrial, and project construction markets in the Philadelphia area. With his electrical distribution experience, he's been able to transition seamlessly into renewable energy. He believes that there is enough sun for all of us to shine. Having energy storage coupled with your renewable energy system adds resiliency, reliability, and increases security for the customer. Thanks, Michael, for being here. I'm really looking forward today to your presentation on fully integrated turnkey commercial and industrial energy storage solutions.
Thank you for having us. I say us because I represent Fortress Power, even though I am one person, but thank you for having me. I'm going to share my screen. I am more of a collaborative type person. So if someone wants to ask me a question in the middle, I don't mind because I believe in having conversations. I'm a conversationalist. So you can ask at any time, a question of me because I believe that my job is to know my material inside out, so you can interrupt me at any time. So what we're going to do is go over our offering. This presentation will give you a brief overview of what Fortress Power does, and then go over our East Power 233 turnkey solution. So about Fortress Power, we are located in Southampton, Pennsylvania, which is right outside of Philadelphia. And we actually just moved to Langhorne, Pennsylvania into a new office. So our business has been expanding that now we need more space, and we have been blessed with the ability to be able to move. We were founded in 2017 by a group of private equity investors and solar veterans. We use third-party logistics centers. Our strategy, if we look at the map, you see California, Texas, Florida, and you see up here in Pennsylvania. Our strategy is to minimize the freight costs of our customers. So this is why we have our third-party logistics centers across the country in pretty much the major time zones where you see solar battery installations kind of going to the highest amount. In addition to these warehouses, we have distribution partners all over the United States, Canada, and other places. We have some major installs, South America, Europe, Middle East, Africa. So we are truly a global company with installs all over the continents. We're on 5 continents to be exact. And we are a key lithium battery supplier for Southeastern Pennsylvania Transportation Authority, which is a major railway in Pennsylvania. The genesis of Fortress Power. Jing Yu, she is our CEO. She is the visionary that started the company, and she actually worked for a panel company called Wanico, and she went to school for electrical engineering and also got a degree in renewable energy. She partnered with a gentleman that actually was a solar installer, and they developed a solution for SEPTA, a battery solution. So our first foray into the battery or energy storage market was actually on a commercial site. So this launching of our 480 volt 3-phase solution for commercial ties nicely into the origins of our company. The markets that Fortress Power plays in are the following: residential, RV market, telecom, commercial, marine, railway. We are known primarily for our 480 volt DC battery products. Like I said, we are diving into the 480 volt solution, which is the eSpire solution. This is an overview of batteries. If you're not familiar, 80% of the battery is its chemical. Batteries, in essence, are essentially inanimate objects in the sense that they do one or two things. They get charged and they get discharged. There are a lot of people that are in the solar world that get nervous and say, I don't understand batteries. And I 100% unequivocally disagree. Everybody on this phone at some point in their life has had a cell phone, has had a laptop, has had a wireless remote control that uses batteries. When you look at batteries, it's pretty much the same philosophical principle inside of batteries. So how well a battery gets charged and discharged, 80% of that is based on its chemistry. So what we like to do is say that all batteries aren't created equal, and we give you an example of the lithium technologies. Before lithium batteries were popular in energy storage, there was a chemical called lead acid batteries, which is very similar to a car battery or a battery that you would find in like a lawnmower and things of that nature. Those were the batteries that proliferated the market. The problem with those batteries was the off-gassing of the battery, having to put water to the battery and things of that nature. Also, the short amount of life cycles. So the new generations of batteries use lithium technologies, and inside of lithium, there are two dominant chemistries. So if you notice in this column here, it says LFP, that stands for lithium ferrophosphate, also known as LiFePO4 or LFP. The other chemistry in the market is lithium ion, and it has nickel, magnesium, and cobalt on the end. Those are the two dominant chemistries. The chemistry that Fortress Power uses is the LFP, and the reason why we consider ourselves a premium battery provider is because we use this chemistry. We're not the only battery company in the market, but LFP and lithium are the dominant battery chemistries. And what are the differences? First of all, which is probably the most important, is what we call the life cycle. So if you go to an LFP battery, these batteries generally give you on average about 6,000 life cycles. A life cycle is when you take a battery that is 100% charged and you drain it down to 20%. We call that 80% depth of discharge. So LFP batteries are designed to be drained down to 80% and then be charged back up to 100%. That is what we would consider a cycle. So LFP batteries give you 6,000 cycles on average, and while lithium ion or NMC, nickel, magnesium, cobalt batteries give you 2,800 life cycles. The other big thing about this chemistry is its thermal output. When you look at lithium batteries and they talk about safety, the failure point in an NMC battery, temperature-wise, you can put a lithium ion battery cell in an oven and it would catch on fire. But you could take an LFP battery cell, put it in the oven and turn it all the way up to 500 degrees and the LFP battery would not catch on fire. So there is literally about a 500 degree C temperature variance. Lithium batteries in general are very, very safe. So don't get that misconstrued. There may be things that you see, like recently there was a battery fire. Batteries generally don't catch on fire because the battery has a problem. What ends up happening is things such as the battery management system, which we call the BMS. Normally there's a failure there, or something happened on impact that punctured the battery, but generally batteries are a lot safer. And when you're comparing the chemistry, you're looking at a 500 degree Celsius difference in terms of when the LFP battery chemistry would meet a failure. So the dominant prevailing wisdom is that LFP batteries are the safest batteries that you can have on the market. They also give you longer duration, and they also have a lower energy cost when you add in how many life cycles you can get in the battery and then how long it lasts you. So when you begin to look at battery chemistries, what you will notice is that lithium batteries generally have a lower cost point, but the life of ownership of the battery and the energy throughput is a lot longer. And actually our Fortress Power batteries give you 8,000 cycles up to 10,000 years. 10 years, excuse me, 8,000 cycles for 10 years is our warranty. So we give you a little bit more than the average LFP battery. So this is why chemistry matters, because 80% of the battery is its chemistry. So LFP batteries, again, they are superior in safety because they have less thermal runaway. It's at a higher degree of higher degree in temperature. They last longer and they give you lower energy costs over the life of the battery.
May I ask, Michael?
Yes, sir.
Thank you. If you go back to that last slide, why? Or differently put, are Teslas and other electric vehicles, are they using LFPs? And if they're not, can you explain why?
He said that wonderful word. Okay, so let me explain a big thing about, so Tesla, they do use NMC chemistry. So when you take Tesla, you take a lot of the chemistries between LFP and lithium. The biggest difference or the biggest advantage that lithium ion has is that it is the most energy dense battery chemistry, meaning that you can get the biggest motor size in the smallest footprint. So if you were building a car, you would definitely, in the beginning of the genesis of those companies, they focus on nickel, magnesium, cobalt because you could get more power in a smaller footprint. So yes, Tesla, they use nickel, magnesium, cobalt. And when they got into energy storage, they used the chemistry that dominated their battery, like gave them the most bang for their buck. So even the Chevy Volt uses nickel, magnesium, but there's been a big push. LG Chem was another company that used nickel, magnesium, cobalt chemistry. There's a big push now for them all to switch to LFP chemistry. But it costs more, but it lasts longer. But yes, Tesla, they did use the NMC, but to their defense or anybody's defense, the reason was that the nickel, magnesium, cobalt gives you a smaller footprint, thus you can have a smaller space for the motor.
Thank you.
Another thing that I would like to point out when you're looking at lithium chemistry, 80% of the battery is the chemistry, and then also how that chemistry is packaged. There's three ways to traditionally package this chemistry. You can put it in what we call a cylindrical cell, so that would look like your traditional battery that's in your remote control. Then there's something called a pouch cell, and a pouch cell is just a square, it looks like a pouch, like a juice box, like a little sippy juice box that you would squeeze in your mouth. And then there's something called a prismatic cell, and that's a rectangular shape, and it basically takes the advantages of the pouch design because you can get more physical footprint inside of the rectangular square, but it doesn't have the swelling effect that pouch has. So what happens for Fortress Power, we use prismatic cells, which is a premium design, use LFP chemistry, and we have great battery management systems. And again, the battery management system is the thing that interacts with your battery to say if there's too much current coming through and things of that nature. So these are our residential products. We have an eVault 18.5 battery. It's called the eVault Max. It's our second generation of our eVault. It is one of the largest single structured batteries on the market. And the reason why I told you that our eSpire is our new 480 volt solution, because one unique thing about Fortress Power is that we've always had robust battery management systems in our E-Series batteries. So this is our eVault 18.5 and our eFlex 5.4. And that is evident in our ability to scale. So our eVault Max over here on the left side is can go up to 370 kilowatt hours. So you can literally put 20 of these together. Our eFlex, the reason why we call it our eFlex, because it is our most versatile battery offering. It can mount on the floor, it can mount on the wall, it can mount on the shelf, it can handle the electric vibrations if it was in a boat. So this enclosure right here, these ridges are designed as an integrated heat sink, but this can also go up to 80 kW. So when you take a 48 volt residential battery, what you get is the ability to go into 208, 120, or 208, or 120, 240 solutions, which we find in residential homes, because when you go into a true three-phase solution, all you're going to do is take an inverter and put 3 of them together, a single phase inverter, and basically you're putting an inverter on each phase of the system. So we've been doing commercial for a few years now, but the value proposition for Fortress Power is that we can give you the economies of scale. Also, as a company, we have traditionally been inverter agnostic, meaning that we're compatible with pretty much all of the 480 volt DC inverters on the market. Now we have what we call closed loop communication with certain inverter manufacturers, but pretty much if you have a 48 volt DC inverter, Fortress Power batteries most likely would be able to have communications or be able to work with that inverter. Now we're going to dive into the commercial offering. So the eSpire 233 technology is pretty much the same. It has the same battery chemistry, which is LFP. It has the same cell architecture, which is prismatics, but now you get into a bigger structure. So essentially, eSpire 233, and the 233 stands for 233 kilowatt hour of capacity. So you can put 13 eVolt maxes inside of an eSpire. What is the difference between the eSpire residential versus the commercial? The biggest thing is the inverter and the power capacity. So when you get with an eSpire, you are essentially going to a 480 volt, 3-phase, 3-wire system. So when you look at commercial or true commercial voltages, generally you're looking at more storage capacity and a 480 volt voltage. And that's what you will find in most of your industrial occupied buildings that you see around the country. What were we seeing in the CNI space? Essentially, there's residential, and we classify residential pretty much around the 200 kW. This is battery storage size. And then utility scale battery storage is usually 5 megawatts or 5,000 kWh and above. There wasn't too many solutions in that 200 to and under 500 kWh. And this is why Fortress Power dove into the 480 market, because we wanted to provide a service in an underserved market. The reason why a lot of the big companies that have these 5 megawatt capacities, it's the same level of commitment and energy and design for these smaller systems, and they really just don't want to peel away and design those systems. So when you get to a question?
Oh, I did have a question from Mark Costa. Says, all this information is so helpful. Thank you. Question: when it comes to system sizing, what recommendations do you have for long-term backup power for homes or commercial or even public sector buildings that really need it to have uptime in disasters?
Okay, so this is where it gets confusing. And you have the right person, and I'll explain to you where it gets confusing. A lot of times the question or the decision about uptime and what we call resiliency or backup, you are comparing batteries to generators. And a lot of people say, I have a generator that runs 24 hours. Well, in reality, that's not true. Generators have a finite amount of gas that they can go on unless you have like a direct line going to the gas, so natural gas. But if you have a liquid propane tank, but what ends up happening is with a generator, you can back up the site for 24 hours because you can keep installing gas and there's no downtime. When it comes to batteries, batteries generally have, lithium specifically, have about a 2-hour charge rate. That meaning that it takes 2 hours to fully charge a battery up or fully drain a battery. So when it comes to giving resiliency for residents, the given resiliency for a home, I'm gonna go back a couple slides. This eVault battery is thought of like a 12 to 16 hour battery. The eFlex battery is thought of like a 2 to 4 hour battery. I mean, in terms of how much time can you have backup. But when you're deciding to back up your home, and this is not in my slides, but again, this is my area of expertise when it comes to electrical distribution. Most homes have basically a 200 amp panel in their house. And most people only use about 50% of that panel ampacity, so 100 amps. So the inverters in these products give you about 50 amps pass through. So essentially that's three rooms that you can have on in the house, because most panel boards have 15 amp circuit breakers in them, so that's like 45 amps. So generally, because we use about half of the ampacity, you would get 6 circuits in a home. So when someone is looking to back up their home with batteries, we like to ask the question, number one, what are you backing up? Because generally you're wiring up what we call a critical loads panel. You're wiring up a central loads panel. So if someone was to say, how many days of backup would I need? eVault, we consider basically a 24-hour battery, because it'll last you through the night, 12 to 16 hours. So if someone wanted 5 days of backup, then in general, they would need 5 eVaults. That's how we look at it. So when it comes to energy storage, it's just very important to understand that a battery gets charged from 3 predominant ways. The one way is the grid, which we call utility. The other way is having a generator. That's something that can charge a battery. And the third way, which is the most popular way, is usually solar. So your batteries are usually getting charged through the solar. And then as they're charged through the solar at night, if the batteries needed some more power and you wanted redundancy, you would actually add a generator and a battery in the same system. So for a backup, what we end up doing is we're looking at the power, and I'm gonna just go through a couple slides so you can kind of see the solution and give you even a more thorough answer. So the eSpire 233 system is a 125 kW inverter. That is the power. So if someone had a solar array on their building, and let's say that solar array was 100 kW, the question that we would ask you is, how much of that solar array are you looking to use and store in the battery? So if someone had, for instance, 100 kW solar array and they wanted to back it up for 2 hours, then this system would back up that solar array for 2 hours. If they wanted to back up that 100 kW of power for 4 hours, then they would need to go to 466 kWh of storage. So we look at the power, and literally it's just math. So if someone has 100 kW for easy math and you want to back it up for 6 hours, then you need 600 kWh of storage, is how the math works. But the eSpire solution is 125 kW of power. This cabinet is 233 kWh of storage, and then you have our control panel. The unique thing that Fortress Power offers in the market that we use to differentiate ourselves is that inside our control cabinet, we give a microgrid controller standard in the cabinet. In addition to the microgrid controller, you also get energy management software. That is what's going to allow you to view your data and analyze your system. So our base package is what you see on the left: the inverter, the battery, and the control cabinet. We give you the EMS software. So you have a lot of people in this market that may sell you the battery and the inverter, and they tell you that you have to figure out the controls. Well, you have people that give you a microgrid solution and tell you that you got to figure out the EMS software. Also, we offer a package where we give you what we call our true turnkey solution. And that's when we give you the relays to sense the grid opening. We'll give you a contactor to open and shut the grid. We'll give you black start. And some of these terms, you might not be familiar with, but you have a choice with Fortress Power to get a total solution from us, and you don't have to worry about piecemealing it together. One thing that I would like to point out is that we are not installers. We are a battery manufacturer, and we provide solutions. So if someone wanted help installing the product, then they would have to reach out to the installer. What we are ensuring is what I like to call the handshake, that all these devices are talking. The microgrid controller that we have gives us the ability to do dynamic peak shaving. It allows us to do load shifting. It allows us to do off-grid operations and backup. It allows us to do energy arbitrage. So we have a pretty powerful microgrid controller built into our system that can handle most of the applications that someone will want or need when it comes to redundancy, resiliency, if you want to go off-grid, if you want to go on-grid, or if you want to be in what we call a true autonomous backup solution. But if someone was building something for a residence or an industrial plaza, and let's say they wanted to have full autonomy and go off-grid, you would then recommend a generator to supplement, just in case there was a cloudy day and the solar array couldn't fully charge the battery or give enough energy. So what I like to tell people is when you think of battery storage in the terms of what's out there in the market, yes, we want to lower the carbon footprint that generators produce. And one of the biggest ways it does is that when you add battery storage, I'll see sites that used to use a generator all the time, spending money on diesel fuel. They add batteries and they might literally have to use that generator in terms of days 5 times in a year because the battery is doing all of that work and cutting that cost out. I'm gonna go through a couple slides. This is showing you what the inside of the battery looks like. These are the packs, these are the modules. So there's 5 battery modules inside of the system. These are the dimensions of the battery. So it's a nice size system. We're talking about something that's basically 5,000 pounds, 920 pounds. The thing that's also nice, we don't have a containerized solution. We have these individual components. So these are all designed outside and you're not fixed into what we call a standard package. Because a lot of times containerized solutions, they'll say, okay, we'll give you 1 megawatt, we give you 2 megawatts, but we can have an asymmetrical system, meaning that you can have 3 cabinets, you can have 5 cabinets, you can have 9 cabinets, just depending on the arrangements. I mean, again, this is just a high level overview, and I'm going to go to the last slide. So this is what a system would look like for us. And this is not a full one line, but just this to give you a pictorial representation. The cabinet here is the inverter. That's the 125 kW inverter. And inside of here, there are 3 DC bus connections. So you can take 1 cabinet to 1 inverter, or you can take 3 battery cabinets and connect it to 1 inverter. The maximum amount of cabinets here, on inverter cabinets, it's 5. So essentially you can go from 125 in power up to the 625 in power, and you can go from 233 up to 3.5 megawatts of energy storage. So every time you buy a system from us, you're going to get these 3 components. Then bypass this is the team right now that is forward facing. So if someone wanted to get in contact with me for a quotation, this is my contact information, my LinkedIn. I'm available on LinkedIn, and Kyle is my commercial industrial sales engineer. And the last slide is not going to match any of the other slides, but this is the value proposition that we give to the market. The eSpire 233 is the right choice for the market because we have the right chemistry, the right cooling system, the right intelligence, right applications, right size, right support, and right availability. The one thing that I didn't mention is that we use liquid cooling. That's primarily seen in a lot of utility scale batteries offerings, and we're using that liquid cooling in the commercial and industrial space. As I mentioned before about our EMS microgrid controller, we can provide you with fleet management. So if you buy multiple systems from Fortress Power, you will be able to see every site on the website. And that's my 30 minutes. Actually, I finished 3 minutes sooner. Any questions?
Woo!
Great job, Michael. There are some questions here. Thanks for giving us a couple moments to ask them. So Gigi Merkel wanted to know, where can these be located, especially for dense urban housing with limited outdoor space? So what are...
So when you go to urban houses, generally houses are going to be 48 volt. So there's not going to be this commercial solution. It's going to literally be what we call, sorry for going fast. It will be something like this. This E-Flex, we have an enclosure that I didn't show that can mount outside, and it can literally sit on the side of the house, or it can sit in somebody's garage. So in the urban spaces, what you see a lot of going on is what we call community solar. So like in New Jersey, things of that nature, you'll see this random, I don't know where you guys are in the country, but in New Jersey, you'll drive past and you'll see a random field, or in New York, you see random fields of these solar panels. And what they do is what we call the new gig economy. They'll allow somebody that lives in an urban area to invest in this solar panel. And then based on the amount of energy that you are paying for, they'll deduce that off of your electric bill and things of that nature. So that's usually in those what I would call high rises type applications where people take advantages, because you're not going to really see these in people's apartments and things of that nature. But in single dwelling spaces, absolutely. Now you could have somebody that has an apartment that wants to buy a battery bank, they will put it outside in an enclosure. If you went with the e-Spire, it would be like on the back of a building. Plenty times from a electrical distribution type thing, you've seen the green pad mount transformers, you'll see the 90 inches high piece of equipment, it would just be on the side of a building.
Excellent, thank you. Let's see, there's praise for you, of course, lots of praise. Just hunting through all the compliments though. And
like I said, I'm a conversationalist by nature. I believe if you need the slides, then you don't know your presentation, right? You have to be the presentation. So that's why I said we can ask. Now I see something, let's see, love the demand management feature. Yeah, so we have the demand management feature. And like I said, for outdoor dwellings, you're really not going to see a lot of e-Spires for homeowners because homeowners generally are on what we call a split phase voltage. So that's 240, 120. So you're looking at a single pole breaker, you're looking at 40 amp 2-pole breakers. So they would primarily be in a residential type application because voltages for homeowners and tenants are usually not 480 volts. So you would see the e-Spire on something like a Walmart, something like a Home Depot, a hospital. That's where you would see this style battery.
a question from Imani. They want to know, have you considered the carbon footprint, the relative carbon intensity, the pollution quotient of these batteries? Do you have any thoughts on their relative merits in the environment?
Well, when you look at batteries, the only thing that you have to worry about is the recycling aspect, because there is no off gassing or anything from the battery. And the beautiful thing about the LFP battery specifically is that in the nickel, magnesium, cobalt chemistry, we can't recycle that because the cost of recycling is just very, very expensive. So when you have this type of battery chemistry, what ends up happening is they last about 70% life after 10 years. And they just kind of reuse it and put it in different form factors, these little toys for your kids and things of that nature. But everything inside the LFP battery is actually 100% recyclable. So there is no gases, there are no chemicals. It's just that market of recycling and refurbishing, that's going to be an emerging markets because batteries really of this sort has just hit the marketplace and they last for so long that hasn't really become an issue.
Thank you. One more question here, then we're going to break for lunch and then we'll be back. Mark Costa wanted to know, do your batteries ever participate in virtual power plants or ancillary services and use the IEEE 2035.5, et cetera? And is that part of your turnkey offering, these virtual grid?
Well, some of these virtual power plants, generally when you look at residential batteries, there's programs that I'm very familiar with in the Massachusetts area where we call demand response, where the utility then say, hey, we want to use this battery to help offset our energy supply. I mean, that's based on the inverter being able to talk to these. So we don't necessarily have a virtual power plant that we promulgate as a solution, but yes, it can participate in that marketplace from percentage of a utility, because utility will call on these batteries and they will give homeowners a deduct based on using the battery. So they'll say, hey, we want to use your battery for basically 60 times a year. How much are you going to be willing to give us? So people sign up to give 5 kW, 10 kW, and then they call on that. And that's essentially a virtual power plant for the utility. But there are some battery companies that create their own what we call virtual power plants, but we would call that demand response. To the question of the lithium titanium oxide battery chemistry, I don't have any familiarity with it. There are new chemistries emerging on a routine, regular basis because some of the laws are basically mandating that you go to batteries. So people are always looking, and a lot of these technologies, I would say, are 4 to 5 years off. There's a zinc oxide battery that's really getting all the buzz. It's supposed to be better than all the lithium chemistries. It's just not on the market yet, so I wouldn't be able to give you a thorough answer. What I would like to say in closing, when you are examining a battery, the reason why I said in my bio that having solar without a battery is an incomplete system, this is the reason. Solar inverters, we don't get anything else, are designed to be synchronized with the grid, and it makes logical sense. A solar inverter is synchronized with the grid because if you were to lose power for a reason and the sun is still shining, the solar panel still will collect that energy. So the solar inverter is designed to shut off so that it does not send power back down the line if someone wanted to work on the system. Also, the sun doesn't shine all day. So in order for you to take advantage of your solar in the cases of if the grid were to go down, so like in California where they have rolling blackouts, or in the Northeast where we have ice storms, in Florida where you have hurricanes, if you wanted to be able to have power during those events, you would have to have a way to store that energy. So we had that major crisis in Texas where they had that ice storm, and they talked about the reason why we don't have power is because of these solars. No, the reason why you don't have power is because you don't have backup. So when you think of batteries, batteries are essentially a safe, harmless generator when it comes in terms of backup. When it comes in terms of cost, batteries are very expensive. So what people will begin to do is use the battery more than just for backup situations. For example, now instead of just using your battery for backup, at night you're going to say, I'm going to power my house at night from my battery. Why am I powering up, the TV and this and that? I can save money. So when people spend money on batteries, they miraculously find more ways to use the battery just because of the cost. But in terms of off gas and things like that, you don't have that in the lithium LFP chemistry.
Thank you.